Good morning, everybody. My name is Miss Gibson, and we will be continuing with the nervous system. And today's lesson is going to be focused on neurons as well as reflex actions and the reflex arc. So, what we're going to learn today, the objectives are by the end of this lesson, you will be able to name, describe, and state the function of each type of neuron, as well as you're going to be able to define and explain a reflex action and a reflex arc. Okay, so what is a neuron? Neurons are basically nerve cells. Okay, they are one of the specialized cells of our bodies, just like the blood cell. They are adapted specifically to do one job. So all neurons have a cell body. We're going to talk about the structure. They have a cell body, and this cell body contains all of the basic organelles that you will find in basically any cell. Okay, so the cell body includes structures like cytoplasm, and as well as it has a large nucleus. Okay, other than the cell body, we have dendrites. Neurons, they have dendrites which conduct impulses towards the cell body. So they're like little attachments or little hair-like fringes that you're going to notice as we go through the slides. Okay, they conduct impulses, and these impulses are in the form of electricity, basically current. Now the axon is the pathway, okay, of which these electrical impulses are going to move from cell body, from one neuron to the cell body of another neuron. So axons will conduct impulses away from the cell body of one neuron and towards the cell body of another adjacent neuron. And another thing is that neurons are surrounded by what we call a myelin sheath, okay, which is a covering or coating that insulates the nerve fiber, and this insulation will cause the transmission or the movement or flow of this electrical impulse to go faster, okay? Okay, is everyone with me at this point? Okay, so we're going to move along. There are three types of neurons, okay? These specialized cells come in three different forms. They all look different from one another. They're going to have a different structure as well as function. So the structure of the neuron really dictates what the job it has to do, okay? So there are three types. The first type is the sensory neuron. The second type goes by three different names, but it's the same thing. The intermediate neuron, or you can call it the interneuron or the relay neuron, okay? All names means the same type of neuron. And we're going to get into that in a minute. And you have your motor neuron, okay? The sensory neuron. The sensory neuron is a neuron that carries nerve impulses, or what we like to call messages, from the sense organ to the central nervous system, which is comprised of the brain and the spinal cord. So sense organs would be organs like your eyes, your ears, your nose, your tongue, your skin. These organs are going to be responsible for detecting stimuluses around you in your environment. So for instance, the eyes will detect light, the ears will detect sound, the nose and the tongue will detect chemicals in the air, in fluid, and of course your skin, which is the largest sense organ of all, will detect a myriad of different stimuluses like touch, pain, temperature, heat, and cold. Okay, let's move on. So now how does this sensory neuron look? Okay, I want you to keep in mind what the function is. The function is to carry electrical impulses from a sense organ to the CNS. It could be either the brain or the spinal cord. Okay, and moving along, we'll see that the sensory neuron has the three parts, well, four parts in common that I spoke about earlier. What's most noticeable about this sensory neuron is the location of the cell body, okay, which looks like a little circle off to the side, right in the middle of the cell, okay? And in the cell body, you will see a nucleus as well as the cytoplasm, okay, which is all of the fluid that is surrounding the nucleus. So this is a cell that you would normally be familiar with. Okay, now remember that these neurons are special. These are specialized cells, so they're going to look uniquely different from any other type of cell. Okay, so the structures that I want you to notice is the axon. Okay, notice how the axon runs straight through the neuron. And at each end of the axon, you're going to see the dendrites, okay, which are like the finger-like branches, okay, that are going to reach out and connect to an adjacent neuron. So at one end, you have the dendrites that doesn't have these little tiny dots, okay? These are the axon terminals that is actually going to pass on the electrical impulse from one neuron to the other. And of note, the other thing that I want you to recognize is this insulation layer, okay? In the that's called the myelin sheath, okay? If you notice, wrapped around the axon, because remember, the electrical impulses that are coming from your sense organs are traveling through this axon. And what we wanted to do is travel very quickly. And this myelin sheath ensures that this electrical impulse, or basically current, continues in one direction very quickly. Okay, so the most distinguishing feature of the sensory neuron is the location of the cell body. Okay, it is off to the side in the middle of the neuron. Okay, and at either end, excuse me, and at either end, you're going to find the dendrites. Okay. The next neuron is called the motor neuron. Now, when I think of the word motor, I think of movement, okay? Like the motor in your car causes your car to move. The motor attached to a boat causes the boat to move. So I'm thinking about movement here. So the motor neuron, the job of the motor neuron is to carry impulses from the brain or spinal cord, which in essence is the central nervous system, to muscles, glands, tissues, or organs. Okay, these are called effectors. So these effectors are going to bring about a response in your body. Okay, whatever the message is in the electrical impulse, the muscle, tissue, organ, or gland is responsible for bringing about that response or reaction. Okay, so remember, the electrical impulses are now being transmitted from the CNS to a muscle or gland, and this will bring about a response or movement in the organism. Okay, now maybe I need to slow down a bit. But let's move along, and I think I'm going to answer the questions afterwards. Okay, this is the motor neuron. If you look at this neuron, you will see that it looks completely different from the sensory neuron. Okay, and I actually want to pause here and, excuse me, I want to find out from somebody who can tell me, what is the major difference or something that stands out to you? What is different between this neuron, the motor neuron, and the first neuron, the sensory neuron? If anyone can tell me the answer. I actually want you to see it before I say it. Do you see the difference? Okay, I'm hearing the dendrites, the axon terminal. Yes. Amaya and Adrian. Yes. The cell body. Okay, so the cell body, the location of the cell body differs between the motor neuron and the sensory neuron. Yes. Everything else, basically, all of the other structures are there. We have the cell body, we have a myelin sheath, we have an axon, we have a nucleus. Yes, the difference in structure is really the location of the cell body. So in the motor neuron, the cell body will be located at the end, okay, of the neuron. Whereas in the sensory neuron, it was located in the middle of the neuron with dendrites at either end. Okay, that's the most distinguishing feature between the sensory neuron and your motor neuron. However, the structures are still the same. They're going to perform the same functions. So here we have the cell body in the motor neuron attached to one end of the cell. And you still have exactly the same structures. You have the nucleus as well as the cell body, which contains the cytoplasm. Now, what's interesting is that in the motor neuron, the dendrites are actually attached to the cell body. In the sensory neuron, there were no dendrites attached to it. Now, if you remember what the function of dendrites are, it is really to connect and transmit and pass on that electrical impulse from one neuron to the other. Now, because these neurons are attached end to end, and because the motor neuron has the cell body at the end, then the dendrites will be attached to the cell body, if that makes sense. Okay, we're going to watch a video that's going to show how they connect to each other, so it's going to make sense. So moving along, the cell body, attached to it is the long axon, okay? Now this axon is also covered by the myelin sheath, okay? Which is the insulator. Remember, it causes the electrical impulse or that current to move quickly, okay? So the direction of the message, you will see it's traveling from left to right, okay? These messages or impulses, they always travel in one direction, okay? One direction all the time. And at the other end of this cell, you're going to see the same axon terminals, okay? These are where the juncture or the space meets another adjacent neuron, okay? So this is how they're going to be attached. Axon terminal to dendrite cell, axon terminal to dendrite cell, okay? And so on. Okay. The third type of neuron is called the intermediate neuron. Now remember, this neuron has three names. You can call it the interneuron as well as the relay neuron. Now this neuron is found in between the sensory neuron and the motor neuron. Hence intermediate and hence interneuron, hence relay. Okay, so it is the go-between, okay, the sensory and the motor neuron. Okay, it is the middle guy. You will find it, the messages cannot get from the sensory neuron to the motor neuron unless it passes through an intermediate neuron. Now, the location of the intermediate neuron is interesting because you will only find these neurons in the central nervous system. Okay, and remember, the two organs that make up the central nervous system are the brain and the spinal cord. Okay, and more specifically, they're going to be located in the gray matter of the brain or the gray matter of the spinal cord. They're not going to be found anywhere else in your body. For instance, you can find sensory neurons in your fingertips, okay? You can find motor neurons in your fingertips, but you will never find intermediate neurons anywhere else in your body other than the central nervous system, okay? Now, because of that, the structure of this neuron is going to be very different from what we've seen so far. Okay, and before I tell you, I would like someone to tell me what is different, what stands out about this neuron. Let's just take a look at what's going on here. I see just a cell body basically with dendrites attached to it, and it has an axon, but who can tell me what is different? What really stands out about this particular neuron versus the other two? Can anyone tell me? What would you say is different? The length is shorter, no axon terminal, the myelin sheath. Okay. There are dendrites around the cell body. Well, that is common, Dariana, that is common to all, but I think someone got it right. Philip, yes. The length has shortened. Okay, so the entire cell is a lot smaller than the other in terms of length. It's shorter. But what specific structure is actually shorter? That's what I wanted to get at. Chioma? Yes, the axon. Okay, the axon. The axon is much shorter. Okay, correct, the axon. So let's look at it one more time. If everyone can see the cursor, here it is. That is the area that is the axon. It's very, very short. Remember, this neuron is only found in a confined space, okay? Either in the brain or the spinal cord. So it doesn't have to be stretched out long to reach another intermediate neuron as it would if it were in your arm or say your leg, where it has to travel feet away. Okay, remember, these are only found in your brain or spinal cord. Okay, so on these type of neurons, the axon will be very, very short. Okay, and just like all of the other neurons, you will see that there are dendrites attached to the cell body. Okay, with axon terminals that is going to be able to attach to an adjacent interneuron or intermediate neuron. Okay, just let me check. I'm seeing that there are some questions. Okay, yes, the axon is shorter. Awesome question, Kaya. I hope I got your name right. Her question is, why is only one arrow facing another way from the rest? Okay, so arrows indicate direction, right? So all of these arrows that are pointing inward into the cell body, this one, and so on, this is the direction of the electrical impulse coming into the cell body, okay? And notice there is only one arrow that is pointing away from the cell body. And this indicates that this branch here in particular is the axon. Okay, remember the axon is the pathway into which those messages will travel from one neuron to the other, okay? So no matter the neuron, the axon will allow these impulses to travel from one cell to the other cell. So that is why in this diagram, you see you have these different arrows, okay? So information coming in to the cell, hence these arrows pointing inwards, and then you have only one arrow that is pointing outwards. Okay, Kaya, I hope that answered your question. So does it only leave from one side of the cell? Okay, if I'm understanding your question correctly, yes, because these impulses only travel in one direction. Okay, so it's coming in from one end of the cell and leaving, okay, the other end of the cell. Alrighty, so remember the impulse is always traveling in one direction. Okay, it never flows back, always going continuously in one route. And that is also important to remember when we talk about reflexes. Why is the axon very thin? Good question, LaShawn. Okay, the axon is thin because you really want rapid, quick responses, right? That's what our nervous system does. We don't want to take an entire week just to make one movement or react to anything in our environment. So these impulses travels very quickly. Okay, the reactions happens very quickly. And you'll learn that in reflex actions, these actions are even happening more quickly in reflex actions. So yes, they're thin to allow the easy transmission and rapid transmission of these electrical impulses. So if it were any thicker, then that will slow down, okay, the transmission of the electrical flow. Okay, LaShawn, I hope that answered your question. Okay, let me get to one more question. So was, yes. So all of these signals are going or flowing in one direction, okay? So information is always coming in at one end of the cell, okay, and going to the other opposite end, okay? So let's with what is a reflex action? It is an automatic, okay, response to a stimulus. Key word in there is automatic. Automatic means you don't have to use your brain. You don't have to think about it. It just happens, okay? And it is a response to a stimulus, meaning that something has to trigger you to create a response, keyword, automatically. Okay, now a reflex arc is the pathway in which the impulse travels to bring about this automatic response. Okay, so it is like the highway to getting our response from stimulus to response. Okay, does that make sense, everyone? Okay, I think that is very important. So I want to make sure that we're all together. Okay, great. Okay, great. Okay, so let's move on. So here are some common examples of reflex actions. Okay, when light goes into your eye, your pupil automatically changes in size, okay, going from very wide to very narrow. You get jerky responses in your hand or legs if you are pricked by a pin, okay, you flinch back. Coughing and sneezing, if something like an irritant were to enter your nasal passage or your throat, you automatically would cough or sneeze, okay? And the knee-jerk response is a very popular example of a reflex action which happens when you take a blow directly to your kneecap, your leg just automatically jerks forward. Okay, if you touch a sharp object, you will move your hand very quickly and suddenly. If you touch a hot object, okay, or even a cold object, you will move your hand away very quickly. Okay, and even blinking like I'm doing now. Okay, if too much breeze is getting to your face, you will just blink automatically, or if an insect goes in it, you will blink, of course. So these are all examples of things that happens in our daily lives, okay, that would be classified as automatic responses, okay? Now, what is interesting, what we're going to learn is how all of this happens automatically. And it happens automatically in the reflex arc. Remember, the reflex arc is the pathway, okay, of which these electrical impulses will travel to give us a response. And this graphic right here shows us how the three neurons, how they play their role in bringing about this response, okay? So the very first neuron is the sensory neuron. Okay, remember, notice how you can tell it's a sensory neuron because the cell body, where is it located? Directly in the middle of the cell. It does not have any spiky-like projections or dendrites. Okay, it's just a smooth cell body. Next, you're going to have, in turn, you're going to have your interneuron. Okay, remember, you can call it your intermediate neuron or your relay neuron. This will be found in the central nervous system, okay, in your either your brain or your spinal cord. And then notice how it is basically a cell body with dendrites attached to it with a very, very short axon, okay? And remember now, these arrows are showing you the direction of the conduction or the flow of the electrical impulse, okay? Remember, one smooth direction is going in all the time. So your interneuron will be found in your CNS, either your brain or spinal cord, and attached to that is going to be your motor neuron. Okay, notice how the motor neuron, the structure is different from your sensory neuron. Look at the location of your cell body. In the motor neuron, it is found at the very end of the cell. And of course, the dendrites are going to now attach to the dendrites or the axon terminals of the interneuron. And then you have your conduction of the impulse continuing to flow down the axon terminal, down the axon until it gets to the axon terminal of this neuron. And here, it could be attached any one of the effectors that we spoke about. It could be a muscle attached here at the end. It could be a gland. It can be an organ. It could be a tissue, okay? Anywhere in the body that is bringing about the response, okay? Is that clear to you? Good. Okay, so let me get back to it. So remember, this is the sequence, okay? This is the sequence or the order in which you will find the neurons in relation to this reflex arc. So remember, the very first neuron will be your sensory neuron because it detects the stimulus. It senses what is happening around you. And then as you passed on, that is the electrical impulse is going to be passed along to the interneuron, secondly, which is found in your central nervous system. And then last, your motor neuron will carry out the response, okay? Hence motor, okay, movement. So that's a very simplistic way of looking at it. Here I have another graphic, okay, of the reflex arc. And you see a lot of things are going on here. Hey, okay, let's break it down. So here we have the sense organ, which is in this example, the skin, okay? And we have the stimulus. The stimulus is this cactus tree, okay? Which has a spine that's being stuck into a finger. Okay, so this skin is on your finger. And here we have your sensory receptors that you're going to find in your skin detecting this pain that you feel when you prick your finger. And this electrical impulse now, indicated by the arrow, is going to travel through that sensory neuron. And we know it's sensory neuron because look at here, the location of the cell body. It's going to follow through that neuron and look at what's wrapped around it, the myelin sheath, okay? It's going to aid in very, very rapid transmission of this signal. And it's going where? Where is this going into? It's going into the spinal cord. Okay, it's going directly into the spinal cord. And in the spinal cord, you're going to see that the sensory neuron is going to be attached to the interneuron. Now remember I said that the interneuron, they are located in the gray matter, okay, of your spinal cord and your brain. So in the gray matter of your spinal cord, you're going to see the relay or interneuron there. It's being attached to one end of your sensory neuron. But I want you to notice something that is interesting, okay? And you're going to see it in the video that's going to precede this. You're going to see that even though, yes, Ms. Gibson said that these impulses only travel through your spinal cord, okay? But look at it. There is also a pathway that leads to the brain, okay? And I'm going to explain to you in a minute. But when we talk about the action itself, the reaction, the impulse will travel through your spinal cord to bring about that automatic reaction. Now, why does it go to the brain? Well, if you want to make further decisions about whatever you are doing, say you are in a fight or flight mode and you just run, okay? Something scares you and you just run. Well, are you just going to keep running forever and ever? Well, maybe it was just a false alarm. And how are you going to know if it's a false alarm? Well, because some of that information had to travel to your brain for you to make a conscious decision about whatever stimulus that occurred to bring about your response. Okay, I'm sure I'm going to get questions about that. It is explained in the video, but let's move on. So moving along, remember we're in the central nervous system in the spinal cord. This impulse will now travel from this neuron, the interneuron, into your motor neuron. Notice that the cell body is located at the end of the cell. Okay, so this electrical impulse or signal will further travel along this motor neuron until it reaches the effector organ. Okay, in this case, the effector organ is the muscle tissues in your arm. Okay, because that is where the stimulus was detected in your finger. So automatically, very, very quickly, as soon as you touch that prickle, your hand will jerk, okay, backwards away from it. And that is bringing about, very, very lastly in the arc, it's bringing out the response, okay? So here you see a very seamless, okay, sequence of events that happens along this reflex arc. Okay, I have a question. Okay, Ryan says, what about conditioned reflexes? Ryan, I'm going to write that down. Conditioned reflexes. Okay, yes, I'm going to answer that question, Ryan, as soon as I'm done with these slides, okay? So very good point, Ryan. Any other questions? Everyone understands? Okay, Latara, I'm going to need you to ask your question that you want me to go over. What is the ventral root and what does it do? Okay, so the ventral root is simply the location of the spinal nerve. Okay, so ventral means um, dorsal means back, ventral means top or above something. So this is the forward root, okay? So this is the front, the ventral means the front of the structure, and dorsal means the back, okay? That's all that means. Okay, it is not important, too important for you to know at this point, but what's important for you to know is the sequence, what's happening with the arc. Okay, let me see time. Okay, I think I have enough time. Okay, is everyone following so far? Okay, so if you did not follow this one, I have another graphic I would like to show you. Okay, so this is actually the very same thing. It is the very same thing, and this is the diagram that you'll probably most likely to see on examinations. So here we have the same thing. We have a stimulus. In this case, the stimulus is pain by heat, okay? And again, you have the same sense organ, which is your skin in your finger. So these, as soon as your receptors in your skin detect that stimulus, that will translate into an electrical impulse, which will travel from your sensory receptors in your fingertips, and it will travel along your arm, okay, and into your spinal cord, where it will meet the relay neuron. Now remember this loop here? This loop here is telling us that some of that information is actually being relayed to the brain. But in terms of bringing out your automatic response, that signal will pass along to your motor neuron, and then finally it will reach your effector, which in this case is your muscle, and the response will be to contract and draw your arm back, okay, to remove yourself from the danger. Okay, now I hope that explained it. Okay, I'm going to go back to your questions. Is there any questions so far? What is the purpose of us feeling pain? Well, yes. Okay, Ryan, yes. Remember, we're all animals, right? And our instinct is, one of our main instincts other than shelter, other than food, is survival, okay? So these are all mechanisms in place to ensure that we don't bring ourselves in harm's way, or to remove ourselves away from harm's way, so that we increase our chances of survival, okay? So if you keep your hand on something hot too long, what's going to happen? Okay, what's going to happen? If you touch something that is too cold, what's going to happen? Okay, so you're going to eventually lose a function of that body organ. Okay, yes, it's going to burn. Okay, and if it's going to burn, you're going to have to, either if it's not lost, you're going to have to go through a lot of healing, right, to get that that function back. Okay, so Denzel is also asking, what is a condition reflex? Don't worry, Ryan and Denzel, I'm going to answer that in a minute. Okay, if we don't feel pain, what happens to the neurons? Well, if we don't feel pain, it probably means that you have some type of problem or injury to either a nerve or the brain or the spinal cord. Okay, but if everything is working, Jabez, you're supposed to feel pain. You're supposed to feel. Okay, now if you don't feel pain, it's because maybe your fingers are numb. Okay, like if you're cold, very, very cold, the very, very first body parts to get numb is probably your nose and definitely your fingers and your toes. So that could be a reason that you don't feel pain either. But let me move on. I think. Okay, So if you notice those two graphics that I showed, no matter how differently it looks, it all had the same sequence of events, okay? And we can put that in the flow chart, okay? So this flow chart here shows the flow or direction or pathway of a reflex arc. It all starts the same and it all ends the same. Okay, and these red arrows basically shows the direction that the electrical impulse is going in. So here we have the very first thing is the stimulus. Okay, the stimulus is the thing in your environment that's going to bring about a response. So in our two examples, the stimulus was pain from a prick and pain from touching a hot candle. Okay, so from stimulus, you're going to get the electrical impulse is going to be detected by a receptor, which will move on or pass along to the sensory neuron, which will pass along to the relay neuron. Notice where it says it's located in your spinal cord, and then it will pass on to your motor neuron, and then pass on to your effector to bring about the appropriate response according to whatever the stimulus was. Okay, so you have stimulus, receptor, sensory neuron, relay neuron in your spinal cord, the motor neuron, effector, could be a muscle, a gland, a tissue, an organ, whatever it needs, whatever it is to bring about the appropriate response. Okay, remember, these actions are automatic. Okay, you do not have to think about it. Okay. Okay, now before I move on, I would like to answer Ryan's question. His question is, well, what about conditioned reflexes? Conditioned reflexes is a type of reflex that you learn over time. So things like blinking, a baby born, okay, a baby is born just blinking. A baby is born knowing as soon as a nipple is in its mouth, it's going to suck, okay? So these, all of those examples that we spoke about before were things that were innate, okay? Innate means that we are just born with these abilities, okay? You don't have to have any prior knowledge of it. As soon as something flies in your eye, you're going to blink. Now, conditioned reflexes are different in that you learn these over time, okay? So an example of a conditioned reflex is, let me keep it simple, the ice cream truck, okay? Hearing the ice cream truck and that particular jingle, you automatically think of sweet, okay? And maybe for some of you, your mouth may start watering, or maybe as soon as you hear it, you run to get $2, okay? So that is an example of a learned reflex, okay? You have to be exposed to that behavior over a period of time for your response to that behavior to now become automatic. So in the beginning, it is not automatic, but through you going through the process of being exposed to that particular behavior, does it now become an automatic response? Okay, and that is why we call it conditioned. So you basically condition your nervous system to create a reflex pathway for a particular behavior that is not really to the everyday person, say to a baby that isn't really eludes to bring in about a response. For instance, a baby, if a baby hears an ice cream truck, nothing will happen, okay? Because a baby really doesn't have any experience over time with something like that. Okay. I hope I have answered your question.